Today, we are going to learn interrupts in microcontrollers, especially in the 8051. What is an interrupt? An interrupt is a signal that forces the CPU to temporarily stop executing the main program and immediately respond to an important event. Normally, the CPU executes instructions one by one in sequence. But when an interrupt occurs, the CPU pauses the current program, saves its current state, executes a special routine called the interrupt service routine, or ISR. After completing the ISR, returns to the main program and continues execution. So, an interrupt allows the system to handle urgent events without disturbing the main program. Why interrupts are needed? Without interrupts, the CPU must constantly check devices using polling, which wastes CPU time, slows down response, reduces efficiency. With interrupts, the CPU responds immediately. No need for continuous checking. Better performance and faster systems. Interrupts are mainly of two types. One is hardware interrupts, generated by external devices. Two is software interrupts, generated by program instructions. Interrupt sources in 8051. The 8051 has 5 interrupt sources. External interrupt 0, INT0. Timer 0 interrupt. External interrupt 1, INT1. Timer 1 interrupt. Serial communication interrupt. Each interrupt is connected to a specific hardware event. Interrupt vector table. When an interrupt occurs, the CPU jumps to a fixed memory address called the interrupt vector address. Each interrupt has its own vector address where the ISR starts. This allows the CPU to know which interrupt occurred and which routine to execute. Interrupt enable concept. Interrupts will not work unless they are enabled. The 8051 uses the interrupt enable, i.e., register to enable or disable individual interrupts. Enable or disable all interrupts using the EA bit. If the global enable bit is OFF, no interrupt can occur. Interrupt priority. Sometimes, 2 interrupts may occur at the same time. To handle this, the 8051 provides an interrupt priority system. High priority interrupt is executed first. Low priority interrupt waits. Priority is controlled using the interrupt priority IP register. Interrupt service routine ISR. An ISR is a small program that handles the interrupt event. Important points about ISR. It executes automatically when an interrupt occurs. It must be short and fast. It ends with a ready instruction. After ready, the CPU returns to the main program. Interrupt program flow. The complete interrupt flow is: main program is running. Interrupt signal occurs. CPU saves program status. CPU jumps to ISR. ISR executes. Ready instruction executed. Main program resumes. Think: fire alarm system. Imagine a building with a fire alarm system controlled by a microcontroller. Normally, the controller is monitoring temperature and system status. Suddenly, a fire sensor detects smoke or high temperature. The sensor sends an interrupt signal to the controller. What happens next? The controller immediately stops all normal tasks. It jumps to the fire handling routine. Activates alarm siren, emergency lights, fire notification system. After handling the emergency, the controller returns to normal monitoring. Urgent event gets highest priority and immediate response. To conclude this lesson, let us summarize what we learned about interrupts. An interrupt is a mechanism that allows the CPU to pause the main program and immediately respond to important events. Instead of continuously checking devices, the CPU reacts only when an interrupt occurs. We learned why interrupts are important, the different interrupt sources in the 8051, how the interrupt enable and priority work, and how the CPU executes an interrupt service routine and then returns to the main program. Through the example of a push button and LED, we saw how an interrupt can force the CPU to respond instantly, even while the main program is busy. So, interrupts make systems faster, smarter, and more efficient, which is why they are widely used in real-time applications. In the next lesson, we will learn how to write an actual 8051 interrupt program step by step and see how it works in real hardware. Thank you for watching, and don't forget to like, share, and subscribe to learn more about microcontrollers.